of you guys just joining us, we are in our notes alternating series test. I kind of just introduced the idea that I want us to get as much practice done as possible today so that we can not only get down the test itself of an alternating series and how to check for its convergence versus divergence, but also if we were prompted, like David said yesterday, if the screen popped up and said, well, what kind? Could we also give the description from exactly or describing exactly what type of convergence? So I'm kind of introducing the idea that depending on how your brain works, depending on what you latch on today, you might start this test in a different way than I do, or in a different way than the rest of the class does, or maybe you can find the way that works best for you. Okay. I'm checking these out really quickly. Number 3 and number 4 are very straightforward. 5 and 6 are a bit more adventurous. So let's do 3 and 4 together, then we get you guys playing on 5 and 6 as I work out with Ryan a few missing assignments, and then we can come back and keep going. Just a quick reminder, what makes numbers 3 and 4 both alternating? Negative 1 to the power. So negative 1 to the power, pretty much right away, we could say by the alternating series test, we know that that's the test that we need to use. Like, that's pretty much a straightforward, no big deal. Or at least that's the direction that our head is going. Now, depending on what we see, maybe we could have started a different direction, but by alternating series test, if we are thinking about alternating series, there are 2 things that need to be true. What's the first thing that needs to be true? Of the non-alternating, which is 1 over square root of n, needs to be 0. Is it 0? The answer is yes. Does that tell me it converges? No, but that's going the right direction, but only for alternating series. Number 2 says the nth term, just kidding, the n plus first term needs to be smaller than or equal to the previous. Is that true? Yes, for all integers, positive integers, 1 to infinity. Okay, so what can I say? Now what if they were to ask me, pop-up screen, okay, fine, absolute or conditional? Why are you saying, Kevin, conditional? Is that what you're saying?
Because of P series, if you do the series from 1 over square root of n, it diverges.
I'm going to put this in a different color just to kind of reiterate that it might not care. And this series does converge. This series does converge. If it's one of those like, hey, here's 10 different series, and here's 4 different series, what converges? 1, 1 and 2, 1 and 3, 1 and 3 and 4, 1 and 2 and 3 and 4. You guys know the AP. If they did that, this converges. Done. Okay? But coming back, what if they asked us what type? We could ask ourselves, what's going on with the absolute value of negative 1 to the n? Is that the exact same thing as? Negative 1 is gone because a negative says negative, positive, negative, positive. I just said absolute value, which means always positive. Right? I'm ignoring the alternator. Guys, what would this series do, or what would it be if I ignored the alternator? So what does this lead us to? What type of convergence does it have? Conditional. Yep. It's only because of the alternator. It wouldn't be otherwise. So here's the dealio. One strategy is to ask ourselves first if it's absolute. Because if it's absolutely convergent, it's convergent and we're done. But in this one, if I had gone looking for absolute convergence at first, absolute convergence, do you converge? No. This doesn't tell me whether or not it converges. This just tells me that it's not absolutely convergent. I would then have to go and do the alternating series test and say, oh, okay. The absolute value doesn't, but the actual series does because of the alternator. One strategy is to go first looking for absolute convergence, which, if it's absolutely convergent, you're done. If it's not absolutely convergent, well, okay, this only tells me that it's not absolutely, so go check for the conditional. The way that we took was start looking for the conditional, then have to check for the absolute. Now, I know some of you don't need to write this out, but still, it's a process that needs to happen in your brain at some point, especially if they're asking for not just convergent or divergent. Sorry, not just convergent, but what kind of convergence it has. Are we okay with this being convergent and this being conditional? Okay. So what's going on with this guy? First of all, why am I saying by alternating series test? What would be the one case or the one time that I shouldn't even write that because it's not even necessary?
There's no line condition.
If the limit as I go to infinity is
Constant zero.
anything that's not zero. Nth term test. If it fails the nth term test, it doesn't really matter. So whether you're going for absolute convergence or whether you're going for conditional convergence first, whether you're going to the alternating series test or whether you're ignoring the alternator and seeing what's going on, if it passes, I shouldn't say that. If it's not divergent by the nth term test, then we can proceed forward. If it is divergent by the nth term test, just stop. There is no need to go any farther. Okay. Some of you guys are already starting to think about condition 1 and condition 2, right? But why in my brain would I actually not have looked here technically at all?
Because it converges BC.
If I consider the absolute value. Kevin's saying it up here. He's saying it converges. It meaning not it, but it meaning the absolute value. Converges by P series. P is equal to 4, which is greater than 1. So I could throw in, since the absolute value converges, then what's the important part? It converges. Or if the pop-up screen comes, I say it's absolutely. I don't technically even really need to think about the terms decreasing and a sub n plus 1 being less than or equal to a sub n. And similarly, to be honest, the nth term test, if I can see that the absolute value converges. If the absolute value converges, if I can see it quick, awesome. Hey, I'm done. It's absolutely convergent. It converges either way, conditional or absolutely. It's convergent. The alternating series is convergent, but how it's convergent is different. Would I have passed step 1? Yes. Would I have passed step 2? Yes. Would I have known converges? Yes. Would I have needed to have gone and checked the absolute value if they asked me the pop-up screen? Yes. But what's nice is if you can see that the absolute value is convergent, just go straight there would be my advice. It's not a requirement. It's just my advice. So I'm showing you what my brain is thinking through. My brain is thinking through the nth term test. My brain is thinking through the absolute value. And then like, okay, well, if I don't know anything yet, now it's time for me to go ahead and check conditions 1 and 2 of alternating series. Converges? Yes. Pop-up screen? How? Absolutely. Okay, cool. Is that okay? Alright. Ready, set? Have fun with 5 and 6. You guys in your groups, you can just keep it in your notes if you want. If you want to go to scratch paper in the back of your spirals, you can totally do that too. Ooh, 5 and 6 and 7, even more fun. Oh, we already did number 7, didn't we? Sorry, we already did number 7 yesterday. Just do 5 and 6. All right, right.
I've done all. I'm like.
I didn't realize I didn't
I'm on the step right now. The comparison.
Yeah, I'm making up your test. Oh no, here. Ah,
If you do absolute value and then divergent, it doesn't necessarily diverge.
If I'd updated earlier, you would have been.
I'm not saying
Yes.
you only get to do the alternator. Like for example,
So like, why is this higher? I guess
How
like
would
you
you
add it
mark
to the
that? I
denominator.
would need those to
Like whenever you add to the denominator.
Making notes first so that you can go.
It's like why 1/2 is greater than 1/3. Right?
so I can
And
like
then
so you guys
given
have
to
not just alternating series.
and the second
Like
one.
yeah, you can do absolute value
The
convergence.
6 is times 2
Yeah, but
BC.
you have to do both of them.
Yeah, like yeah, like just
For those of you guys that came in late today, I did mention if anybody had not yet gotten their chapter 9 back, just kidding, it hasn't formally been passed back, but some people realized it was done and we're getting them from me. Go get a correction paper because they're coming back in just a second.
So it's
I have
not
papers if you want it.
Chapter 9 as in L'Hôpital's relative rates of growth
Yeah.
sequences, not series.
Linear compared to n plus one.
Do you want more than one?
Yeah.
You want test fraction equals or something?
I'll,
I already did
yeah.
it.
How you guys just run statistics at school?
That's two. 1 over.
Because the first term is
Everyone gets two.
why did you get 1 over square root of n plus 1?
I don't know. To see if that equals 0.
No, tell them because
Are we
our
number 5?
sequence is 1 over square root of n and 1 over square root
Oh,
n plus
so
1.
I'm looking at
It's indicating the next term.
also you need 1 over square root of n plus 1.
I'd rather have a D
1
than a
over
C.
n plus 4.
Square root of n plus 4.
Oh.
It's smaller than 1 over square root of n.
Yeah, that makes more sense. I would have circled
It's just
it.
for
Here, I can show you where D
Wait.
is.
Why was because it's the square root?
I know
So that's
It's red.
easy, right?
So
It's okay, Abby.
I didn't do bad. I didn't
Do
do
I say
bad.
D?
You get half point
A
back.
B? Oh yeah,
Yeah, I got a
it's 89.8.
That's good. Fuck.
I know.
Pretty good.
This is it.
So would that be
Would that be 1 over square root of n? Wait.
That could do be like that.
Oh, we already go to test first.
I already got this because it's just the one we were comparing.
Wait, did you say to get it first?
Yeah.
So when we compare n plus 1,
separate effect of only use like half the time to just defend the test.
so then should we do 1 over square root of
Wait, are we
n?
doing number 6?
Number 5.
Oh, never mind.
She said she's passing me a test.
Oh.
David, are you confident
Because
you go
this
for
plus
it?
3 is
Alright, so
or is it just square root of n?
It's the Air Force doing
Air
it.
Force?
Airport.
Oh,
Where's Air Force
Sure.
going?
yeah.
Is it? What do you mean?
So then,
I mean, you said you were selling.
Oh, AirPod.
Yeah, airport.
I need a big old one.
Okay.
I'll pass it.
And then
What are you
for
selling
n,
AirPods now?
plug in n plus 1.
I'm giving him a AirPods Pro for like
If that's true, then
I won't order it.
I'm not
I
making
don't
you
need
profit,
it.
but it's okay.
or at least the absolute value.
I'm selling it for that.
So when is the approximate time to
And the absolute value is
I don't know. I told my friend and he's not telling me anything. He said
So why does 6
he said like
look
2 to 3 weeks, like 2 to 3 weeks is the line.
Because
Yeah.
it's
So I don't know.
just
Like,
just
you'll get it as long as you want to.
I'm just wondering.
yeah. And then even
How,
in degree
how
terms,
does
then you go
1
to
over
infinity
square
and
root of n plus 3
and
differ?
means
One
exponential.
averages.
Yeah.
If you compare this to
That's
one
and then
over
the
square root
When
of
we're
n.
comparing
the argument
that's
has
the
information as the
repeating
limit
if
is the
it's
limit
direct and
Of
indirect?
the
Indirect
has
or
information does not equal 0.
Correct.
that's our
So
answer.
you're writing the thing.
I have this.
This is our answer.
Oh, because you're adding big like numbers that are bigger than 0, so it goes. Yeah, that makes sense.
I mean, it's talking about number five.
Yeah, this is number 5.
I showed you
Yeah,
what
but if you
Mario
limit
was.
one, it's square root of n plus 3, whatever. It's okay, square root of n and then
I
square
have
root
a
of n plus
C,
3.
David. Are you trolling?
Oh.
The limit,
Oh
you
no.
do the limit and then you times it
Agent,
by
ready?
I did like this.
oh, I'm sorry. I pulled the paper.
Oh, I folded it. Did you?
Okay, let's go.
Oh, what kind of question for you?
Oh my god. Oh my god. Oh my god. Jacob. Oh Okay, there were a few places on this that you guys could have definitely gotten mixed up. Quite a few of you got mixed up around number 9. Around number 9, a lot of you got the limit to equal 0, which in some ways you were right. You just forgot that it was ln of y equals 0. You have to take e to the power of that 0 to finish the problem. A few of you guys got messed up around the, where was it? 1 over 0, and you should have stopped. Here we go, number 7. Some of you did L'Hopital's way too many times because technically only one iteration of L'Hopital's led you to infinite form, 1 over 0, so you shouldn't have kept L'Hopitaling it. After one iteration, you had 1 over 0, which led you to an infinity. Need to check the sign as to which one. A few of you guys got scared That was number 13. A few of you kind of mixed it up a little bit. If you totally mixed it up, sadly, on number 13, like multiple ones were in wrong spots, I had to cross it off. If you just didn't realize that ln of 3 was a constant that was, bless you, in between, no, lower than e. Yeah. If you didn't realize that ln was lower than e, but everything else was right, I'd probably give you half credit on that. And then a few of you guys messed up either your integration by parts in number 16. Oh, there's integration by parts in number 15 too, right? In both of them? Yeah. You might have messed up your integration by parts a little bit too. Anyway, those were some of the most common mistakes that I remember as far as when I was grading this, which I was grading it a while ago. Sorry, it's been on my desk ready for you guys to have for a little while. When did I grade it last? Oh, I guess I graded it last Friday. I got behind last week. I meant to give it to you before the weekend because you didn't really have homework, but then you guys enjoyed not really having homework. And
Yes.
So I just let you have it. The quiz is not totally done yet. Lo siento. Because I was updating RenWeb. So you can check out RenWeb and see it's been updated in all my classes as of yesterday with everything but Google Classroom. Google Classroom, if you always turn everything in and if your homework spiral is 100, well, your grade should stay the same. Google Classroom, if you never turn anything in and your grade in homework is, and your homework spiral is 100, well, then it's going to go down. If your homework spiral was really bad and your Google Classroom is really bad, it might be about the same. Anyway, I don't know. Google Classroom is the one thing that's not in there. But everything else is. Oh, I was looking at your old seat, Iris. That's why I was so confused. I'm sorry. I was confused as to why so many people. Okay, but Christina's not here, and John's not here, and Patricia's not here, and David's not here in the classroom, and Dean is still coming.
I left and he was here, and then I came back and he wasn't.
We completely
Now
honest.
you know.
All right. Dean, I'm going to go ahead and put your dress upside down on the laptop. You probably found that too. Okay. You haven't already got it.
Okay, can you also
We talked about that.
All right, cool kids. Let's see how you did.
You want to start?
Would this, I'm just curious. Ready? Would this have been a good one to go looking at the absolute value right away? But the last one, if you went to the absolute value, you were done. So why is this good or not good?
Not good.
Why not good?
Because it diverges.
Well, how do you know it diverges?
Integral test.
What?
Integral.
Yes, if you do the integral test, considering 1 over the square root of x plus 3 is continuous positive Oh, don't worry, you're okay, because the discontinuity would be at -3, and I'm not going to hit -3 as I go from 1 to infinity. Okay, so positive, continuous, decreasing. The integral of 1 over square root of u is going to be u to the 1/2 times 2. Wait a minute, when I go plugging in an infinite b to a square root, doesn't that go to infinity? Now, whoa, I just did the integral test in my head, but so did Lorenzo, so it's not totally crazy. But, what am I trying to show you? If I went straight looking here, it would tell me nothing, even if I did a lot of work with the integral test. What do you mean it tells you nothing? It tells you divergent. No. It tells me by the integral test, if I was to follow that line of logic, it tells me that the absolute value diverges. And I'm not doing the whole integral test, and here's why I'm not doing the whole integral test. I would, and make sure that you guys all understood why the answer is divergent. But I know nothing from that. It's not a part of my proof. All I know is that the absolute value diverges. So what do I know if the absolute value diverges? That this is not, second screen, absolutely convergent. But what do you not know about the original? You don't know whether it's convergent or divergent. You just know it's not absolutely convergent, but it could be conditionally or divergent. Does that make sense? Now, the one up here would have been super smart to go absolute value because it was one and done. Like absolute value convergent. Done! Absolutely convergent. Yay! But this one, you could have done integral test and seen it was divergent. You know nothing. So then the smarter idea on this one, if you were trying to do this not just well or not just properly but also efficiently, would have been to say, hey, you know what? I know the limit is 0. I also know that, what would n plus 1 plus 3 end up being? Is that always going to be less than or equal to n plus 3? For all positive integers, yeah. Yeah, that's a bigger denominator, smaller number. Bigger denominator, smaller number. Me, right? I'm taller. Bigger denominator, but oh, I was below Abby. Smaller number. There you go, Janelle. I got you.
Thank you.
Done, done, done. It's conditionally convergent. Why conditionally? Well, I know it's convergent, and I would have been done, but if the pop-up screen came, I also know it's conditionally convergent because Lorenzo and I thought through the entire integral test. Would that be enough to prove it? I'm not sure they would necessarily enjoy that justification. Now, I thought through it. Don't worry. Trust me. However, for right now, for us in class, let's go ahead and go for it and say the series is conditionally convergent by the alternating series test. What's the other way? What other test besides the integral test? I think I would have done limit comparison. Because direct comparison, we have to think about who's bigger or smaller. It's a headache. But couldn't I have just compared it to 1 over root n? If I compare it to 1 over root n, it'd be root n over root n plus 3. The degrees are tied. The limit is 1. What 1 does is the other. And what is 1 over root n? Divergent by p series. P is equal to 1/2. Either way, to be honest, for some of you, limit comparison would have been faster than integral test. Limit comparison would have been faster than integral test. But either way, if you know divergent of an absolute value, you know nothing about the actual convergence of the original without the alternating series. How about number 6? Oof, you guys must have spent forever on that one.
Yes.
No, just diverge.
Yes.
Just diverge.
If you just started, why should you have stopped real fast? It diverges by the nth term test. If the limit is anything other than.
Look at your previous endeavor card. Yes, it diverges.
If it equals 0, we know nothing. Or we know the first step to alternating series. If it doesn't equal 0, we're done. It's divergent. Remember, nth term test finds divergence. Proves divergence. Number 7 we did yesterday, so I'm throwing him in parentheses because he should have already been in our notes. Yeah.
So on the AP, can you just write limit as n approaches to infinity of n plus 1 over n equals 1? Because or would you have to include the alternator in the limit to prove by nth term that the
I'm using what is technically in our endeavor card for alternating series, that if number 1 fails for the alternating series, then the entire series fails by nth term test. But Joe, I appreciate that you're trying to fine tune the particulars. To be totally honest, because why not? I rarely, if ever, see an actual justification or explanation to a convergent or divergent statement as a function.
so you have to say that?
There are places where the work needs to be shown as like a part A to a much more involved Taylor or Maclaurin. Or a final answer needs to be shown as convergent or divergent. But since it's rare, I don't think I necessarily off the top of my head have a good answer for that right now. So keep an eye open when we start doing practice AP. And when we do start doing practice FRQs, that's when you can bring that question up again and let me go ahead and search in Google and see what we've got. Or maybe minimum day tomorrow. I'm trying to catch up on grades, but we can try to do that too. So it's in my head. Yeah, it's a good question as to whether or not you would need to state it. It's like a L'Hopital's fine-tuning of what you exactly need to show. For right now, for your basic understanding, I'm good with that. But yeah, let's keep an eye open on what the AP teaches. And whether or not, to be honest, if it's a Taylor Maclaurin, I thought so that kind of puts it in a category in my mind as to where I'm not sure it matters, but I do want you to have a proper response to that. Why do we like this one? Which means the limit is 0, which means. Oh, wait a minute. Hold that's a good thing that it equals 0, right?
Yeah.
I mean, technically for any series, it's a good thing it equals 0 because that means it might converge. It's a bad thing for us having to keep on doing more work. But alternating, I have half my test checked off. So hold on, what happens if I take the limit as n goes to infinity of, we now need to think about ln of n plus 1.
Wait.
Oh, sorry, I did limit when I meant to just plug in n plus 1. I now need to think about what's going on with n plus 1, right? Okay, this one's smaller, yeah, I agree. How about ln of n plus 1?
Bigger than ln, so it's the whole
Because ln, no matter what, is strictly increasing also. Well, wait a minute. Can't ln sometimes be negative, though? When is ln negative?
smaller than
When it's below the axis, it's below the axis before its x-intercept, and ln in all logarithms, unless they've been shifted, always hit where? Log of what is always 0? 1. Oh, well, it doesn't matter, because 1 is before 2. Oh, so that's okay. So, as long as I'm past 1, ln is strictly increasing and positive, so positive increasing numbers, yes, that will be less than or equal to 1 over n ln of n. Okay, so this is one of those like quick multiple choice thingamabobs, and this one, they're just asking like which of these are convergent. What can I say? Yeah. The main selection, like yesterday, as far as like white or Asian or South Islander, Pacific, whatever, I don't remember how they say that, or like Hispanic, or okay. Yes, it converges, right? Done. Dun 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 dun. But why am I not going to stop? What if there's a pop-up box, right? What if there's a pop-up menu? Okay, like on the SAT when you select, or the AP or whatever Dave was talking about, I don't know, it says something pops up and then there's like an extra, oh, okay, but what type? So what type? Well, I don't know. What would I have to check to see what type? I'd have to check the absolute value. Does that make sense, Adrian? We'll say yes because I heard the light bulb turn on. Thanks, Patty. And ln n. I would need to check the absolute value to be able to make the additional. What am I trying to say? The additional choice? No, the additional label, the additional. Come on, you guys have good vocabulary.
I don't know.
Conclusion. Sure.
I wasn't listening.
Honestly. Sorry. I appreciate it. So, just I need you guys to realize if this is one of those like 1, 2, 1, 2, and 3, 1, 2, 3, don't you dare keep going because it's convergent. Just move on. But if they're asking specifically for conditional or absolute, we have to be able to keep going. So why is this a bummer? If you remember that there's a very nice integral test because ln of n can be u and 1 over n is du, so it's really just 1 over u and it's ln of n, which really goes to infinity. Oh my goodness, old homework problems are helpful if you struggled through it the first time. But if you don't have that kind of memory where you remember the difficult word problems that or the difficult homework problems that you struggled through and that we've already seen, is there another way besides integral tests, which for some would be pretty complicated? Limit comparison. What if we were to compare to 1 over n? Why would it not work? 1 over n is divergent. P series P is equal to 1. What's the limit of this if the bottom wins?
0.
Can I have 0 and divergent and know anything from limit comparison? No, I need 0 and convergent or infinity and divergent. Some of you are like, oh, no big deal, make it a 1 over n squared, that's convergent. But wait, who's stronger? ln of n or n? Stink. Now I have an infinite limit with a convergent. What if I do n to the, what's in between 1 and a half? Or sorry, 1 and 2?
1.53.
Okay, convergent. Well, stink. What's stronger though, ln of n or square root of n? Man, all of those are going to keep on being infinite. So what if I was to do something like?
I don't
Wait, Kevin, what'd you say?
I said 5 over 4.
Well, that's where I was going next. But 5 over 4, I have n to the 1/4 and ln of n. Isn't n to the 1/4 still stronger eventually? Yeah, so it'd still be infinite, and that's still greater than 1. So I think whatever I choose, I was going 3/4 next. But 3/4, I'm still gonna have a limit of 0 with a divergent. Struggle. What do I need? I need an infinite with a divergent.
An infinite divergent?
Or a ratio that's the same, but I'll never get that with an ln. Man, is there not a way to use limit comparison? There might not.
Maybe direct though.
Nope, because any powers are gonna get closer and closer and
Like
closer.
oh my god. So what's the limit?
Oh, you know what we could do though? Wait. No. No. I'm not sure we can use limit comparison. It was a great idea. E for effort. Sorry, by integral test. You usually can if the n and the ln of n are in separate places, but if they're in the same place, it's pretty hard because you can't tie the degree without using another logarithm. You can't use another logarithm unless. Ooh. Ha! Got it. Never mind. Limit comparison test. It's awkward. You're gonna hate it, but it's good. No, you're not. It's not gonna work. Just kidding. It was an E for effort.
My route.
Sorry, done. I was thinking if we compared to n squared, and n squared is divergent just because of the nth term test, but then it'd be 1 over n squared, and that's not going to help anyone. So, E for effort. By integral test, series of the absolute value of a sub n. I don't like that. Because a sub n is the non-alternator, that doesn't really make a difference. I'm just going to do that. Diverges. There you go. But for those of you guys that are like, I don't know if I know how to use the integral test for that, you would need to use u is equal to ln of x. Remember, consider 1 over x ln of x. Du is equal to 1 over x dx. And we end up with the integral of 1 over u du, which ends up being ln of x from 2 to b, and the limit as b goes to infinity. ln of, yeah, there you go. And ln of going to infinity is infinity, and going to infinity is infinity. So, hence the infinite improper integral, which means the divergent absolute value. Whoop! Hey, this one's alternating, right? So what am I going to say if I geoseries, the series converges?
Is it conditional?
It's alternating. I thought we always had to use alternating.
If r is less than
It's conditional.
or in between r and n.
Can't I rewrite the -1 to the n over the 2 to the n as -1/2 to the n, and r is equal to -1/2, which is less than 1? Well, whose magnitude is less than 1, hence the absolute value. How are we doing? Just because there's a -1? Oh, hi, Vicky.
Oh.
You're welcome. Let's
I'm
end on this
just
one.
gonna jump ship.
What did it jump?
Jump ship.
Oh, you're jumping. Are you holding your nose? Just get ready to.
I'm getting ready.
Wait, Missy.
I'm jumping.
Hey, think about it.
Throw me away.
P.S. I've seen more and more piecewise functions in the last few years, especially when talking about series.
Piecewise function.
Continuous series.
John, I'm going to grab you your chapter 9 test. I passed it out when you were out of the classroom. Number 10. If I were you guys, I would start writing out some terms. That might be a good
What am
idea.
I looking at?
If I were you guys, I might start writing out some terms. That might be a good idea.
I'm not looking.
If n is 1, n is odd, plug into that one. If n is 2, n is even, plug into that one. If n is 3, n is odd, plug into that one. Who is this guy?
Alternating.
You can define a series in terms of pieces?
I don't like piecewise.
You didn't like piecewise. Piecewise series are even more exciting.
Piecewise series.
Oh, this is where my power of guessing comes in.
Who's plugged in 1 yet? What do we have for our first term?
2.
Second term.
-1.
Oh.
So if you plug it.
Because all of those are going to be positive. All of those are going to be negative. I think it's an alternator.
What?
I said that.
Negative. I'm sorry. My number 2.
be 4 over 2 because it's odd. Plug in 2 would be negative 2 over 2, which would be negative 1. Plug in 3, it'd be 4 over 4, which is 1. Plug in 3. Plug in 4, it'd be negative 2 over 4, which is negative 1 half.
It should be 4/6.
Plug in
This is brutal.
5, it'd be 4 over 6.
It can never be equal with odd.
Oh.
4 over 5 plus 1,
Oh.
which would be 2/3. Plug in 6 and you'd have negative 1/3. Plug in 7, you'd have 1/2. Plug in 8, you'd have, well, negative 1/4, etc., etc., etc. How's this looking?
Things are getting canceled.
Things are getting canceled. Things are getting canceled. Do you wish that we had maybe gone a little bit further?
Yeah.
Made you look homeless. What are we talking about over here?
John's funny, dude.
This heat.
It's a good
Huh.
one.
This problem is like.
Going way over our heads.
Well, wait a minute. Hold on.
Wait,
We start at 1.
We just plugged in numbers. If it's odd, we go.
1 goes here. So 4 over 1 plus 1 is 4 over 2.
Okay, so we've just been plugging in.
And then 2 is even, so negative 2 over 2.
Negative 1.
And then 3 plus 1 is 4. 4 over 4 is
Okay.
Okay.
We
got up to 4 over 8, which came from 7. 7 plugging in 4 over 8 is 1/2. Plugging in 9 is plugging in 7. Plugging in 8 is negative 1/4. Plugging in 9 is 2/5. Plugging in 10 is negative 1/5.
Are you going up to
That
what
1
number are
over
we going up
3.
to?
Can we are we gonna end up rewriting this? Oh, I can't. I tried.
Is it alternating?
Yes.
Yes. But how do I find a formula in terms like one a sub n? Because right now I have 2 a sub n's and they're different a sub n's. How do I get 1 a sub n? Because I need to find 1 a sub n to be able to find the convergence of that 1 a sub n. And is it enough for that? Well, wait a minute. Hold on. No big deal. Alternating series. Are they both getting smaller and smaller? AKA is the limit of each of them as n goes to infinity 0.
Yes.
Oh, good. But what's the second condition that also has to be true for alternating series?
Decrease.
Each term needs to be less than or equal to the previous term, disregarding the alternating sign. Doesn't this go up? Doesn't that go up?
Yeah.
Doesn't that go up? So wait a minute. It doesn't pass the first. No, it does pass the first going to infinity. It doesn't pass the second. Or does it? You know what would be a lot easier? Lainey, why did you say are we going to rewrite it? Some of you were like, wait, something maybe telescoping, something. You can keep writing it all day. It's not a nice telescoping because not everything is going to cancel out. But what do you see? What's 2 minus 1? What's 1 minus 1/2? You can take it piecewise and see if maybe there's another sequence that's hidden in between. Because that's just a third. That's just a fourth. That's just a fifth. What is this stupid thing the exact same thing as?
1 over n.
And what does 1 over n do?
Oh my god.
Diverges by p series. P is equal to 1. Do you see how they can require you to have some creativity even in the midst of all these super set and solid rules and tests?
That's the kind of problem I was describing 2 years ago.
Wait,
That's just not.
This one was rough because this one wasn't telescoping. It wasn't like an all together that you split apart to be able. This was a split apart that you wanted to put together to be able. Struggle.
It is a struggle.
But did you realize how it also failed condition 2 of the alternating series test?
I'm not gonna lie, that's a beautiful math problem.
Hey, I thought so too. How about number 11?
Abby.
Shut up. It's
At
pretty.
the very end.
It was beautiful. It was a pretty math problem. I can appreciate
I know it wasn't my writing, but the problem itself is quite unique. So you guys' turn. Let's see how interesting, how creative, how
Okay. One,
you could process this information in this problem.
2, -1.
Yeah, there you go. Take your time.
-4, 16, -6, 1, 5 is 1, 4. 6, -1, 36.
Six, -136.
Yes. Okay, so it's my homework?
No, not yet.
Okay. Oh, she's writing that.
Oh, she's writing that?
Okay, she's writing that.
44 negative 34 plus. What? Oh.
That's the teacher, Ryan. It's not
Teacher
teacher
34
Ryan, it's
minus
not funny.
Okay.
116.
Mister Ryan.
I even missed the logo.
Plus
So.
6 negative.
And being dumb.
Wait.
Take the negative 48.
Thank you.
I'm just gonna.
Let's find the common denominator.
I don't know why. That's why you want to start soda.
Soda?
Yeah.
Can you say soda?
Sodas. The soda.
You guys given up?
Yes.
No, it's I don't
What's the
understand.
never give up?
My weakness is subtracting fractions.
It's 13/48.
Oh yeah,
Yes, I did.
Cheat.
I am not ashamed.
Some of you are trying to do it the exact same way and being like, oh, 3/4. Oh, wait a minute. Wouldn't that be 16 thirds minus 3/16? I mean, 16/48 minus 3/48. So you have to multiply them by each other.
Yep. Calculator.
That'd be 13/48.
Yep.
Whatever.
The next one, 5 times 36 and 36 times 5.
Oh.
180.
Which would be 31 all over 180. The next one, well, who on earth is that?
Just use the
Alternating
alternating.
series test.
Just use alternating series test.
Yeah. The limit equals to 0, and this term is smaller.
This one, they're smaller?
Regardless of this opposite sign.
I see going down and up and down and up and down and up, right?
Yes.
Here's a dilemma. Some of you guys noticed in the one up above that you were like, oh, the alternating series test failed, so therefore it was divergent. No, actually, I was able to rewrite it as 1 over n, which we were able to prove divergence. Here's the struggle. Does the alternating test apply when you have one series comprised of 2 separate formulas? Can you take the alternating series test of each of them individually, or do you need to get some sort of nth term of all of them collectively? That's the question of the property that we're not sure yet until you figure out whether or not this is convergent or divergent and why. Bye guys, see you later, alligators. After a while, crocodiles. We will pick up with this tomorrow. Nice thing is, homework's not due until Monday. Better get going on it tonight because there's some fun ones. Wait. Collectively or individually? Do we need a single ace of n, or can we work with it with individual ace of n? What you're saying, Lorenzo, you're saying we're allowed to work. But so is 1 over n.
Imagine a series of tests.
But you have to get a formula for it. You see it? But yeah. Because 1 over n is